Hello everyone and welcome to another video on building serverless applications on AWS with .NET. In this video, we're going to have a look at one of the features of xUnit that really easily allows us to create parameterized tests. Now this is useful because it allows us to define the request and response that we expect to see from our Lambda function and pass that into our test at runtime, and we can use that to have one single test that can test the various different permutations of our Lambda function request and response. And we can also use this to test schemas. Let's say our Lambda function is publishing an event to EventBridge. We can use these parameterized tests to make sure that the schema of that published event matches what we expect. Let's get into it. So I'm actually going to start with a feature of AWS SAM, and it's a feature that allows us to generate sample events for the different types of event sources that Lambda has. So if I'm in my console here, and I can look at the SAM local generate event command, and what the generate event command does is we can use it to then generate some sample JSON. So you see we've got all the different event sources that are available to Lambda here. In this instance, we are going to use API Gateway. So I'm going to generate an API Gateway event type, if I could spell. And then there's obviously a few different variations of API Gateway. So there's one extra command we can pass in here. We want an AWS proxy. So if I just do that and put AWS proxy on the end, this will now give me some sample JSON into my terminal that matches the event schema of an API Gateway event. And this applies to many of the event sources available to Lambda. And what we can do just to set up before we get into some of these tests is we can then use that schema to generate some sample JSON. So let's have a look at the Lambda function we're going to be using here for this demonstration. And we've got a Lambda function that's just going to retrieve the IP address of the current executing code. That will be the IP address of the instance that the Lambda function is running on. And then it's going to publish an event to EventBridge, and then it's going to just return a JSON response. It's a bit of a contrived example, but it allows us to demonstrate a few different concepts. And you'll notice, as we've talked about in some of the other videos on testing, we've got both an internal constructor and a public constructor. The public one is what the Lambda service will use. And then we can use this internal function here for our test purposes. So we've got this simple Lambda function. If I go and have a look at my test now, you see I've already generated some sample JSON here for what is a valid request. So there's no body in this request. We have a query string called message. This is what a valid request coming in from API Gateway would look like. I've also defined an invalid request. If I open up my test project again and we look at the invalid request, you see the invalid request doesn't actually include the query string parameter. So now we've demonstrated two potential events that could come into our Lambda function, and we've got one that's good and one that's bad. If we also look at the invalid response now, so this is what we're expecting to see when a request is passed to our Lambda function without a query string, and it's going to tell us a query string then message is required. We've got a status code 400, this is what we're expecting to see. If I look at my valid response, that's obviously slightly different in that I get an actual message back and I get my IP address. So this is all the stuff we've done to set up, right? We've got these valid requests and valid responses, and we can now use these in our tests. One final thing I will touch on in here is I've also defined the schema using the JSON schema format of the event that we expect to be published to EventBridge. So in this instance, our event that gets published should include a metadata field, which has a string field called source, and it should have a data property, which has a string property called IP address. That's what we're expecting in our schema. So let's actually have a look at the tests now. And you can see straight away here, we're using this feature of xUnit called theories. And what theories allow us to do is create these parameterized tests. So we can have a single test method And we can pass in different requests and responses and use them to validate what's happening in our function. So we've defined our theory, and then we've got this inline data attribute, and that's where we can actually define the parameters that get passed into our function. So you see we've got our valid request data, the request, the response, and the schema, and then we've also got our invalid request and response. We don't expect there to be a schema for an invalid request because nothing should be published, so we pass in null for that parameter. And then as we start to look at what's going on within our test now, so the first thing we're doing is we're going to actually deserialize the request and the response into a API gateway proxy response and an API gateway proxy request. So now we've got the strongly typed objects that we can pass into our Lambda function, but then we can also use to validate the response. We then set up a mock of our network service that's always going to return tender.order.1. Remember, these are unit tests, so we shouldn't rely on anything external. And then we're also creating a mock of the Amazon EventBridge SDK client. And we're going to mock out the put events async method, which is what will be used in our function code to publish the event. And we're going to use a feature of mock called callbacks. And that's where we can say when that method is called, here's what we actually want to happen. And what we're going to do is we're going to grab the event that gets published to EventBridge by our function code, and we're going to store that in a local variable. So now we've got two things here. We've got the request and the response of what we're expecting to API Gateway. And then we've also got the object that was published to EventBridge. And then we go off and we invoke our function. We make the request to our function handler, passing in the request and response. And then we can actually validate that the status code should be what we expect. The body should be what we expect. This is really powerful now because I've got a single test and I can run it for these two different scenarios. So if I open up my unit test window here in Rider and I run my unit test, so you see even in my test window, it shows as there being two tests, even though we've only got one single test class and they both pass, of course. You know, if I was to go into my, let's say into my Lambda function code, and I was to just change this to, instead of returning this message, let's just put some invalid data on the end here. And now we'd expect, of course, that our valid request should still pass, but our invalid request should fail. And there we go, we've had one success and one failure, just as we would expect. And that's a really nice way. Now we could validate all these different scenarios, all these different situations that we might expect in our Lambda function just by defining actual JSON objects of what we think are valid and invalid responses. So it's a really quick way to add lots of different tests to actually validate what's coming into and out of your Lambda function. Now, the other really powerful thing here, and especially when we get into building event-driven architectures where schema management becomes really important, is we can also use this similar functionality to test our event schema. Because then we're both validating that A, the event actually gets published, and B, that the schema of that event that gets published meets the requirements and that doesn't change over time. So let's have a look at how we're doing that. If we scroll down in this test class now, let's just minimize that at the bottom there. If we look in this test class now, and we've got this verify event method right at the end, and we're passing in both the schema of the event, and that's the file local on our file system. And then we're also passing in the actual request that was published to Amazon EventBridge. And of course, if nothing was published to EventBridge, this event request would still be null. If we have a look at this verify event now, we are just checking that if the schema, the expected schema is null, then we just want to make sure that the event hasn't been published. And we know if the event hasn't been published because our event request will still be null. But if the event schema passed in isn't empty, we can then use a feature of this NJSON schema library. So if I just open up my dependencies here, look in my CS proj, you see we've got this reference to NJSON schema, and this allows us to use classes to validate JSON schemas against actual JSON objects. So looking at our test now, we load the JSON schema from the file local to our file system. And of course, that's in the events folder and in that valid event schema.json. And then we're going to parse the detail component of the event that was published to EventBridge. and we're going to parse that into a JSON object. So we've got the schema, and we've got a JToken, which is just a JSON object. And then on our schema object, there's this validate method. So we can call validate and pass in our JSON event object. And this validate method will return a set of an array of validation errors. So what we're expecting is that there to be no errors because the schema should match the published event. Again, if I was to come over to my Lambda function now, and when we do this publish to event bridge, we have this new IP address event object. If I was to open that up, and let's say I change the name of my JSON property there, we'll just add some nonsense in to make this easier. And I go again and I rerun my tests. Again, we should expect 1 failure and 1 success. We might actually get 2 failures because I don't think I changed the message back. I did change the message back. Excellent. So you see, we've now got a valid request that has failed because the schema didn't match. We actually use the response of this validate method to build out a more helpful error message when our unit test fails. So let's grab that from there and let's create a error message string, and then we'll also call our, let's get rid of that. And then we'll say for validation errors equals the response of our validate. And then what we can do is loop over that validation errors object. So for each error in validation errors. And then let's just really simply say the error message equals the, let's do this in string concatenation, equals the existing error message plus the error dot, let's have a look, error dot property. Let's just log that for the moment. And then we can say the error message dot should be empty. We'd expect that to be empty. So if this is valid, if this schema is valid, there'll be no objects in our collection of validation errors, which mean that error message will stay as empty because we define it as empty there. And if I come down and rerun my unit test again now, I will actually see the error message that was returned by our validate message. So you see, I'm just getting IP address. So let's try and extend this. Let's make this message a bit more useful. And we will say, what other options do we have on this error.property? So we could say property, let's say error with this property, and then we'll pass in the error dot, let's say kind, let's say pass in the error kind, and let's do that to string. Let's rerun this now and see if we get a slightly more helpful error message. So the test is just running now. That has completed and it failed. An expected error with IP address, property required. So let's extend that a little bit earlier. Reason is property required. Again, run that again. And we'll actually now get a helpful message out to our terminal window. This is really powerful because again, we can just change these events, we can add new requests, add new responses, and really quickly start to validate the input and output of our Lambda function in a way that is really low code, in a sense that we've got this one test method that handles all these different requests and responses. So that's unit testing your Lambda functions using the theory feature of xUnit. As always, if you've liked this video, then please like, please subscribe, please share, and I will see you again next time.